Welcome back, everyone. Up until now, we've spent a lot of time looking at physical hardware, the cables, the routers, the physical switches, but today we are stepping into the matrix. Welcome to CompTIA A plus Core 1, Objective 2.4, the invisible architecture. Today, we master the network configurations that make the physical hardware actually function. Let's get one thing straight right away. Modern networks are not magic. Behind every single seamless video call, every sent email, and every securely loaded web page is a highly strict set of invisible rules. As an IT support specialist, your job is to see, manipulate, and validate this hidden infrastructure using tools like ping, traceroute, and VLAN configurations to keep your enterprise connected and secure. To conquer this objective, we are going to look at the four foundational pillars that govern the flow and trust of enterprise network traffic. 1. The network directory, focusing on DNS. 2. Trusting the mail, managing spam. 3. Automating addresses, understanding DHCP. 4. Shaping and securing traffic with VLANs and VPNs. Pillar 1. The network directory. Humans are great at memorizing names, but computers only memorize IP addresses. To bridge this gap, we use DNS, the domain name system, which operates on port 53. Think of it as the internet's phonebook, translating friendly domain names like CompTIA.org into routable numerical addresses across the globe. Inside that phonebook are specific records pointing to server locations. The two most common are your address records. An A record resolves a host name directly to a 32-bit IPv4 address. However, as the world transitions to the massive 128-bit IPv6 address space, we use AAA Quad A records to resolve host names to an IPv6 address. What happens if your enterprise buys another company? You use a canonical name, or CNAME, record. A CNAME acts as an alias, linking one domain name directly to another. If Company A acquires Company B, you create a CNAME, so anyone typing www.companyb.com is seamlessly redirected to www.companyaa.com without you having to build and maintain two separate web servers. If you are dealing with email, you need an MX record, which stands for Mail Exchanger. This acts as the post office routing system. It explicitly tells the global internet which specific target servers are authorized to accept email messages on behalf of your domain. Pillar 2 brings us to trusting the mail. We use TXT or text records. Originally, these were literally just designed to hold human-readable notes for administrators. Today, they have evolved into the foundation for machine-readable security. They allow us to publish powerful anti-spam policies directly into our public DNS directory. Email addresses are incredibly easy to forge or spoof. To protect our users, receiving servers rely on three specific frameworks published in those TXT records to act as the bouncers of the inbox: SPF, DKIM, and DMARC. The first bouncer checks the guest list, which is SPF, Sender Policy Framework. SPF publishes a strict list of authorized IP addresses. When an email arrives, it tells the receiving server, only these specific VIP IP addresses are allowed to send mail on behalf of my domain. If the sender's IP isn't on this list, they are an imposter. The second bouncer checks the wax seal, which is DKIM, Domain Keys Identified Mail. DKIM adds a complex cryptographic signature to the email header. This acts exactly like an unbreakable wax seal on a physical letter, guaranteeing the receiving server that the message was not intercepted or tampered with while traversing the internet. The final piece is the rulebook, DMARC, Domain-Based Message Authentication, Reporting, and Conformance. DMARC ties SPF and DKIM together. It provides exact instructions to the receiving server on what to do if an email fails those first two security checks, telling the server to either quarantine the suspicious email or outright reject it and throw it in the trash. Moving to Pillar 3, automating addresses. If you manage IP addresses manually, I promise you will accidentally duplicate IPs and break connections. Instead, we use DHCP, the Dynamic Host Configuration Protocol, acting as our network leasing office. It automates IP assignments at scale, listening on UDP port 67 for servers and port 68 for client requests. When configuring DHCP, you must define the scope and the exclusions. The scope is your master planned community. It is the total pool of IP addresses the server is allowed to offer. Exclusions are the administrative lots. These are specific IPs removed from the pool, like your default gateway or a local server. So DHCP never accidentally hands out your router's IP address to a random laptop. Remember, IP addresses are borrowed, not owned. When a device joins, it utilizes the four-step DORA process to negotiate a lease. Discover, the client blasts a broadcast seeking a server. Offer, the server offers an available IP. Request, the client requests to formally use that IP. Acknowledge, the server confirms the lease and locks it in. Sometimes you want a specific device, like a heavy-duty network printer, to always get the exact same IP without statically assigning it at the machine. You use a DHCP reservation. This permanently ties a specific IP address to the physical hardware MAC address of the device. It's a VIP parking spot. Whenever that MAC address connects, the server guarantees it gets its reserved IP. Sometimes you want a specific device, like a heavy-duty network printer, to always get the exact same IP without statically assigning it at the machine. You use a DHCP reservation. This permanently ties a specific IP address to the physical hardware MAC address of the device. It's a VIP parking spot. Whenever that MAC address connects, the server guarantees it gets its reserved IP. Inside the office, we use virtual LANs, or VLANs. A VLAN slices a single physical switch into multiple, completely isolated broadcast domains. By assigning specific switch ports to a VLAN ID between 2 and 4094, you can securely separate the HR department's sensitive traffic from the public guest Wi-Fi, all while using the exact same physical hardware. When users leave the office and enter the chaotic wasteland of the public internet, we protect them with a virtual private network, or VPN. A VPN establishes an armored, encrypted tunnel through the public internet, allowing remote workers to securely access corporate resources as if they were sitting safely at their desks. Finally, the invisible architecture is only as good as our ability to troubleshoot it at the command line. When things break, use ipconfig or ifconfig on Linux to verify your DHCP leases and subnet masks. Use nslookup to manually query the directory and verify your DNS records, and use ping to test your routing pathways across those VLANs and VPNs. You now possess the complete blueprint. You understand how devices find each other using DNS, how they establish trust via spam management protocols, how they dynamically join the network with DHCP, and how we shape that traffic using VLANs and VPNs. You are officially ready to conquer CompTIA A+ Objective 2.4. Excellent work today. Let's head into the labs at XP Boost.